Hello, class, and anybody else watching this. Some breaking geology news. There was just now an earthquake centered in northern New Jersey, about 5 kilometers in depth. Based on what I just last looked at, they might be updating this as they kind of look at their seismic data as it comes in. This is an unusual earthquake, and I am sure it is going to be making news headlines. There are lots of questions about this. One, why is there an earthquake right here? Two, why are so many people feeling it? It's not like we typically have earthquakes here very often. And how does it compare to some other earthquakes? So first off, this is the most recent kind of shake map that I have for the area. So you can kind of see Pennsylvania right here, Great Lakes up here. And New York and New Jersey are kind of covered by all of these shake reports. This is using a scale that is not what most people hear about. Most people know about the Richter scale, the 1 to 10 scale, which is, from a 1 to 10. That is a scale that is on orders of magnitude. So a 4.0 is 10 times more powerful than a 3.0. This scale is based on the amount of energy released from an earthquake. So I've felt a 7.5 earthquake before, but because I was like 100 miles away, I didn't feel nearly the same amount as what somebody else did who is on top of the epicenter. These shake maps use the Mercalli scale, which is more what did you feel kind of scale. It's more qualitative than quantitative, and honestly, it's a better scale for reporting purposes. So people that live in these areas will kind of get on USGS's website and they'll sort of report what they felt, and USGS will kind of take an average of the people that live within these little squares and create a map like this. And if you notice, this was not a huge earthquake, and already we've got reports over a very large area. Last time I checked, this looks like it's going to be if I could write, a 4.7 on the Richter scale. Now, let's compare that to some other earthquakes historically. Here's one that's a 5.8 in Virginia from 2011. I remember this one very well, and if you're old enough and live on the East Coast, you probably remember that one. And then here's one from 2013, about the same size, from California. I snagged this from another YouTuber, by the way, who has the greatest video ever on the New Magic Seismic Zone, and I kind of pulled this screenshot from him. This earthquake over here kind of shows not a whole lot of people felt it. There's not a whole lot of boxes in terms of scale. It didn't travel nearly as far. However, over here on the East Coast, a lot of people felt it, and they felt it in a big way. Why is this? The geology on the West Coast is different from the geology on the East Coast. The rocks over here on the West Coast are much younger, much more faulted, much more folded, and so the surface waves of these earthquakes just don't travel very far before they kind of get muted out by the geology. On the East Coast, the rocks are flatter, older, denser. It is like banging your hand into a table. The other side of the table is going to feel those vibrations very quickly. So that's kind of what causes these earthquakes to travel really far. Now, why do we even have earthquakes over here on the East Coast? Anyway, that is sort of a weird thing. They don't happen very often. Yes, we have this mountain range over here, the Appalachians, but that may not be what's going on with this situation. So West Coast kind of makes sense. You probably heard of the Ring of Fire. There's the San Andreas Fault over there. There's all the stuff in the Pacific Northwest. It's a very tectonically active place. The East Coast is not tectonically active. However, a few thousand years ago, there was a lot of ice sitting on top of the Northeast, and geologically speaking, that is not long ago. When in geology, we typically talk about millions of years, if not hundreds of million years, or billions of years. A few thousand years is not very long on the geologic time scale. And a few thousand years ago, there were miles of ice sitting on top of the crust around here, including right around where this earthquake was. Now, I do not know for sure. I am not a seismologist or geophysicist that is plugged into what's happened with this earthquake. I know it's about 5 kilometers down. That seems pretty shallow to me. However, it's kind of in the right spot to potentially happen due to this phenomenon. So what happens here is these ice sheets have retreated. They're no longer there. That is like taking a bunch of stuff off a boat. And when you take a bunch of stuff off the boat, what happens to the boat? Boat goes up. Yes, very good. A+. So this could be crustal rebound that is causing this small, little, rather shallow earthquake. It's not that unusual. This has happened before. But like I said, I'm not certain. We'll see what the geologists say at the USGS and elsewhere. I'm not necessarily a super big expert on this area. I'm more of an expert in the Ozark regions and also Alaska and Hawaii, so this isn't my field of expertise. However, I'd be willing to bet a few paychecks that this is probably what's occurred. Now, if I'm wrong, feel free to fleece me in the comments. But I bet this is what's happening, and it's kind of neat actually. It's a sort of a different type of earthquake. And if you wonder what this whole kind of there's a big name for this kind of reaction. It's something called isostasy. We see it with mountains as well. As mountains erode over time, they're not quite as heavy, and the crust will kind of rebound a little bit. But this is it on a much shorter time scale with the geology. So, hope you learned something, and yeah, see you in class.